Hey guys, today we are going to take a look at our first conic section, and we're going to talk about the parabola. Okay. Now I know that we've talked about parabolas. We have graphed like y equals x squared or f of x equals x squared because it was a function, and so that's what we're going to start with because you're already kind of familiar with it. The problem is we're going to look at it a different way. We're going to talk about parabolas a different way, and the equations are going to look a little different than what you're used to. Okay, so first off, what is a parabola? By definition, a parabola is a collection of points, so that's not new. Every shape you've ever graphed in your life is just a collection of points, okay? But they're all the points that are the same distance from two fixed objects. One of those is called a focus, which is this point right here, and a line, which is called the directrix, okay? So imagine that you're not looking at this parabola. You have a line and a point in space. That's all you have. A parabola is a collection of all the points that are the exact same distance from those two objects. So this right here, this point in the middle, this is the vertex of our parabola, and you'll notice that this point is the same distance from this point and from this line down here. This is the directrix down here. As we move around the parabola, so like over here, we are still the same distance from the focus and this line down here. So now we're going straight down to measure to this directrix. And this point is also the same distance, and so is this, and so is this, and so is this. Okay? So when we draw our parabolas, we're going to draw this shape, but we're also going to draw this focal point, and we're also going to draw the directrix behind it. When we draw our parabola, to get the shape right, we're just going to draw three things. We're going to start at the vertex, and then we're going to draw this point and this point, which are on either side of that focus right there. And that's going to be the 3 points that give us kind of the shape of our parabola. Okay? And that's it. Now, how we're going to find all these points are all embedded in this equation right here. So this is the equation of a parabola. This is also the equation of a parabola. This is a standard parabola that's centered at the origin, so we're going to start with that. And then this is one that's been shifted, left, right, up, or down. Okay? So, first off, we're going to start with our vertex. Our vertex, in this case, is at 0, 0. Okay? So right here at the origin, this is your vertex. This is how we need to write parabolas. So x squared equals 4 times p times y. So what we're going to have is an x squared on this side, we're going to have a plain y on this side, and then there's going to be a coefficient. There's going to be something in front of that y. We need to rewrite that number as 4 times something. So whatever number you're looking at, you are going to rewrite it as 4 times something. Okay? If it's an 8, you're going to rewrite it as 4 times 2. If it's a 4, you're going to write it as 4 times 1. Okay? Always, it's 4 times something. Don't just take the number out there and split it in just some way. It's always has to be split as 4 times something, because that 4 is part of the equation that you're looking at. So you have to have a 4 there, but this is going to be the important number. This number right here is what we're going to use to find all these other numbers. Okay? So first off, that number is the distance between the vertex and your focus. So right here, this distance is p. The directrix is also p, but it's in the opposite direction. So this is kind of like negative p. These 2 points on either side, these 2 points that are on the parabola, are called lattice points. And these points are 2p in either direction. So 2p to the right and 2p to the left. So that's why that p is important, because once we know our vertex, every other thing we draw is going to be based on that value right there, that p value. Okay? So our focus is always going to be, well, in this case, 0p. Whatever p is, we're going to go up that amount from the vertex. Your directrix is always going to be a line, and it's going to be in the opposite direction of whatever p is. So if that's a 2, then we're going to be at negative 2. So negative p. And then your lattice points are going to be 2p to the right and 2p to the left. Okay, now, this is all going to make more sense when I show you an actual example. Okay, now, parabolas do not have to be centered at the origin. They could also be shifted, and that's all that you're seeing right here. Okay, that h and that k, that's where our vertex is. That's going to be our starting point. Now, remember, notice that there is a minus in the formula. So the number that you're going to be looking at is actually the opposite of what you're going to be seeing. So if you see an x minus 2, then your h value is a positive 2. It's not a minus 2, it's a positive 2. If you see y plus 3, your k value is actually a negative 3, because the reason you're seeing a plus sign is because that minus is getting canceled with a negative over here, and so you're seeing a plus, and so this is actually going to be a minus. So these two numbers are going to come from these parentheses. That's going to be our vertex, and that's going to be kind of our starting point. Okay, so let me show you an example so this will all make sense. All right. So graph the parabola by plotting the vertex and lattice points. Okay, so first things first. This is our parabola. The first thing we need to do is we need to split the number 8 into 4 times 2. 4 is the number that's in the formula that we were looking at, and 2 is our p-value. That is how we're going to move. So this parabola is centered at the origin, so we're going to start at the origin. So that's our vertex. So our vertex is 0, 0. And then we are going to find our focus. So that's that point that's inside the parabola. So we're going to go up 2, and that's going to be where our focus is. So our focus is 0, 2 in this case. We also need to go down to, this is where our directrix is going to be. Now, it's not that point I just drew. It's a line that goes through that point. So our directrix is this line down here. Okay, you could draw a dotted line, you could draw a solid line, I don't care. Okay, but this is our directrix, so that's going to be at y equals negative 2. And now we need to find our two lattice points. So again, however much you go up to find your focus, so this was 2, we are now going to double that. And so we're going to go 4, 1, 2, 3, 4 to the right. And we're going to go 4, 1, 2, 3, 4 to the left. And these 3 points are going to give us the shape of our parabola. That's it. Okay? That is it. Now, look at the second example. The last example, actually. Okay? So, this is not in the standard form that we want. Okay? So, we are going to use completing the square to create something that looks like this up here. Okay? So, x minus h squared. We need this to be a perfect square, and then anything that doesn't involve an x needs to get pushed to the other side. Okay? So, x squared plus 4x, and then I'm going to leave a blank. That's where we're going to complete the square. Everything else needs to get moved to the other side. The 4y needs to come over here and become negative 4y. That's the equal sign. The 8 needs to come over here and become a negative 8. And then one last thing. I'm also going to put a blank over here so I don't forget to balance when I complete the square. Okay? Now, what's our magic number? It's always half of this and then squared. So half of 4 is 2. 2 squared is 4. So that is now a perfect square on the left. I also need to put a plus 4 on the right. This is now x plus 2 squared. This can simplify as well. This is negative 4y, and then the minus 8 and the plus 4 are going to give us a minus 4 when we simplify that. But we're not done. If you look up here, you'll notice this y is in a set of parentheses, and this number is on the outside. So there should not be a number technically connected to the y. It should be factored away from the y. Okay, so let's go down here. So I need to factor this negative 4 away from the y, and we're going to do that because you'll notice that negative 4 is a common factor between these two terms. So x plus 2 squared stays put. We're going to factor a negative 4 away from our y, but we're also factoring a negative 4 away from a negative 4, so that's going to leave us with a plus 1. All right, now this is in the right form. I also need to remember that this number right here needs to get split up into 4 times p. So 4 times what? Well, if I want a negative 4, I need this to be a negative 1. That is the p value. That's going to be important. So where's my vertex? Well, remember, it's the opposite of this number and it's the opposite of that number. So our vertex is going to be at negative 2, negative 1. So negative 2, negative 1, right there. What is our p value? Because that's our vertex. This is going to tell me how to move to get to the focus. It's a negative 1. So we're going to go down 1. That's where our focus is going to be. Okay, our lattice points are going to be double that to the left and to the right. So if I went down 1, I'm not going to go left 2, I'm going to go right 2. So left 2 and right 2. So notice this parabola is going down, which makes sense, because whenever we have a negative, that's going to flip our parabola. Okay, so that one's going down. Our focus, where's our focus? Well, it's right here. Make sure you write it as an ordered pair. This is the point negative 2, negative 2. And where's our directrix? Remember, it's in the opposite direction of the focus. So if our focus was down 1, our directrix is going to be up 1, and then it's going to be the line that goes through that little point right there. So that's going to be y equals 0. So y equals 0. That's our directrix. Okay? Take a look at today's homework. You're going to have some examples where I already give it to you in the correct form. So all you have to do is graph. Those are the first few. And then you're going to see a few where you have to create the standard form by completing the square. So make sure you use this as an example.